video, we're going to be looking at exponential growth and decay, both the models and their graphs. So right here, I have an exponential function. We know it's exponential function when we have the variable, the x, in the exponent. You'll be asked, does this function model growth or decay? What percent is the growth or decay? And what's the y-intercept of the graph? Let's look at the graph first, and then we'll take it away. We can see that this graph increases as x increases. So the y's are growing as x grows. That means we have exponential growth from the graph. From the graph, we can't tell what percent the growth is. But from the graph, we can see it slicing through and hitting the vertical y-axis at 5. So we know that that y-intercept is up at 5, or at the point 0, 5. But what if we took the graph away? Can we still answer those questions? And how? So to decide without the graph whether your exponential function is modeling growth or decay, we focus on its base. In this case, the base is 1.32. If our base is bigger than 1, we'll have growth. If our base is less than 1, we'll have decay. So from the model, I can see that that decimal is bigger than 1. If that had been a fraction, and it was top heavy, like 7/6 or 5/2, we'd also have growth. If we're less than 1, had that been a 0.40, we'd have decay. Or had the fraction been bottom heavy, like 1/3, we'd also have decay. But our next question is, what percent is the growth? For that, we need to focus on its difference between 1 and this growth factor. 1.32 is 0.32 more than 1, hence the growth, which means it grew by 32%. Had that been something less than 1, maybe it was just 0.32, not 1.32. Then we would have had decay, and we'd have to ask ourselves, how far is 0.32 from 1? And we'd have to consider subtracting it from 1. And 1 minus 0.32 is 0.68, so we'd say 68% decay. But this one was over 1, and is over 1 by 0.32 or 32%. The y-intercept, we saw on the graph it was 5, but remember that y-intercept is when the x value is equal to 0. So when I replaced that x value with a 0, we learned in a previous chapter that anything to the 0 power is 1. So I'd get 5 times 1.32 to the 0, which would be 5 times 1, which is just 5. So that lead coefficient, or that lead number, or the a that maybe your teacher talked about when they talked about a times b to the x, that gives us our y-intercept. Pause this video and see if you can supply what goes in the 3 answer blanks. Is this exponential function modeling growth or decay? What percent is the growth or decay? And what's the y-intercept? And do so all without the use of your graph. So for growth or decay, we look at that base, that 4/5, and we ask ourselves, is it bigger than or less than 1? You might want to change it to a decimal, because you're going to have to anyway. But 4 divided by 5 is 0.8, or 4/5 is obviously less than a whole, or less than 1. So that means this is modeling decay. What percent did I lose? What percent does it go down if it maintains 4/5? Well, we need to figure out that distance of 4/5 or 0.8 from 1. How far is it from 1? How much did it go down? So we just subtract 1 minus 0.8, or you could do it as a fraction too, 1 minus 4/5. But because this asks for the percent, I like the decimals. So I'm going to say 1 minus 0.8 is 0.2. which would mean we have a 20% decay. Remember, the y-intercept is determined by that lead number, that 2 out front, because 4/5 to the 0 would be 1, and when we have a y-intercept, our x value is 0. So we would have a decay of 20% with a y-intercept or starting value of 2.